Hi, this is Dana Gardner, Principal Analyst at Interarbor Solutions, and you're listening to BriefingsDirect. The speed and complexity of microservices-intense applications often leave the developers in the dark. They too often struggle to track and visualize the actual underlying architecture of their distributed services. The designers, builders, and testers of modern API-laden apps therefore need an ongoing and instant visibility capability into their rapidly changing data flows, integration points, and assemblages of internal and third-party services. Thankfully, an open source project to advance the sophisticated distributed tracing and observability platform called Hypertrace is helping. Stay with us now as we hear about the evolution and capabilities of Hypertrace and how an early adopter in the online payment suite business, Razorpay, has gained new insights and deeper understanding of their services components. To learn how Hypertrace discovers, monitors, visualizes, and optimizes intense services architectures, please join me now in welcoming our guests. We're here with Venkat. He's an architect at Razorpay in Bangalore, India. Welcome, Venkat.
Thank you, Dana. Thank you for the warm welcome.
We're also here with Jayesh Ahire. He's a founding engineer at Traceable AI and product manager for Hypertrace. Welcome, Jayesh.
Thanks, Dana. Glad to be here.
Let's start with you, Venkat. What does Razorpay do, and why is tracing and understanding your services architecture so important?
So Razorpay's mission is to enable frictionless banking and payment experiences by powering the entire financial infrastructure for businesses of all shapes and sizes. It's a full-stack financial solution that enables thousands of SMEs and enterprises to accept, process, and disburse payments at scale. Today, we process billions of dollars of payments for millions of businesses across India. We're a leading payments provider in the country, and we've been the first to bring to market most of the major innovations in the last 5 years. Over the last 2 years, we have successfully forayed into neobanking and lending. We have seen an outstanding growth in the last 5 years and attracted close to $300 million plus in funding from extremely marquee investors like Sequoia, Tiger, Ribbit, Matrix Partners, and others. One of the fundamental principles about building and designing Razorpay has largely been to build an API-driven ecosystem. We are a developer-first company. Our general principle of building is it is built by developers for developers, which means that every single product that we ever build is always going to be API-driven first. And in that regard, ensuring that our APIs are resilient and they are performing to the best and the most optimum capacity is of extreme importance to us.
And can you give us a sense of why you need better visibility? What is it about being an API-driven organization that makes tracing and observability an important characteristic?
So we are an extremely agile organization. We are a very, very young startup, which basically means customer obsession and focus towards building great quality products is extremely paramount to our user experience. Our customers actually have amazing stories around our projects, products, and ecosystem. We have worked and we are working through extreme times, and that has helped our customers build a lot of trust in what we do and what we can do. Whether it is the demonetization exercise that India has gone into, or whether it is the Yes Bank kind of a debacle that India has seen, we have quickly jumped up, we have quickly taken up the challenge, and we have quickly turned the tables around for most of our customers to build a lot of trust in the kind of things that we do. We are dealing with one of the most sensitive aspects of human lives, which is their money. So in this regard, the resiliency, security, and all other parameters are extremely paramount for our success.
Jayesh, why is Razorpay a good example of what businesses are facing when it comes to APIs? And what are the top requirements that your distributed tracing and observability platform are attempting to satisfy?
Like going back in the days when this all started, right? So people started building applications using monoliths. And it was easy to start with monoliths because it was easy to get started and get the business moving. But in the recent times, that is not the only important thing for businesses. As we heard Venkat talking about scale, Venkat talking about resiliency in the platform and building platform with the APIs, use organizations that scalability, that resiliency in a way. And when you talk about modern organizations, so most of them use microservices in their code. And this microservice evolution, this API evolution has complicated the whole architectures we see today. And this modern complex architectures are hard to manage when it comes to large-scale organizations. Like when you have 100, 200, 300 microservices with thousands of APIs to maybe manage those microservices, in like communication between those microservices and all these things. It's just hard for businesses to have a visibility, have an observability, which can help them to see if there's any issue, to see if the APIs are performing as they are expected, as they're expected to. So I will just list down 4 brief questions which every organization needs to answer at some point. That are the APIs providing the functionality which they are supposed to deliver? Are the APIs performing in the way they are supposed to perform? Are the APIs secure, or are the business users is something they are able to understand through the APIs and microservices? And when it comes to like having to understand how if these APIs and microservices are performing as per the expectations, or if the functionality they are providing is up to the mark, it is very significant to look at something which can provide you those answers to these questions. Not only these 4 questions, but even some of the arbitrary questions in general. And what observability provides is it helps you answer those questions without opening that black box, without going to each and every service, without going to each and every API. The instrumentation data itself provides you those insights. You can ask arbitrary questions to your system and it will give you answers. You can ask how your system is performing and it will give you some answers. And this observability helps this large scale organizations to keep up with the scale, to keep up with the increasing number of users and keep their systems resilient.
Venkat, what are the business imperatives for needing something like Hypertrace? Is this about user experience? Is this about making sure that new services come on board properly? What is the business case, if you will, for why you need to use more observability in your services development?
There are fundamentally 3 legs to what we largely define as modern observability. One part is largely with respect to metrics. The other part is with respect to the logs. And the third part is with respect to the traces. In slightly older world, we had APM systems that sort of used to monitor some of these things, sort of provide this one single place of being able to gather a lot of insights. However, as microservices became a lot more paramount and more wide scale in use, APMs probably aren't the right way to do some of these things. While for metrics, we have a lot of work that is already going on in the open source ecosystem with respect to Prometheus and the whole work that Grafana is sort of doing. On the other side, with respect to log, whether it is the ELK stack, whether it is a lot of log providers, whether in PaaS mode or SaaS mode who are there, fundamentally the issue comes out to be with respect to traces. Now, traces in one sense can be sort of visualized in a very primitive way with respect to just being able to sort of instrument a particular piece of code to understand its behavior. While it could just be a timing function for a particular function call to start with. However, as microservices evolve, you're talking about a lot more basic problems. For example, how much time did a network call take? How much time did a database call take? Which particular database call took what particular time? In the network call, was my DNS request the biggest impediment? Was it really the SSL termination that was an impediment? What really happened in the last mile? And when you're talking about an entire graph of services, it's very, very important to sort of know which particular point in the entire graph sort of breaks down very often or doesn't break down very often, right? Now, understanding all of these things, and like what Jayesh said, asking the right questions to the system cannot sort of just happen only by metrics, cannot only happen just by logs, because they give different slices of the problems, and cannot also happen only by trace. That also gives a different slice of the problem. General, ideal nirvana world, we are talking about combining all of these things and creating this one single place that is able to causate and correlate in terms of various things, being able to deep dive to that particular specific component, module, function, system, query, whatever, right? And being able to identify. I think a root cause identification, the mean time to detection, these are some of the most paramount things that we probably need to worry about. And very specifically in large scale systems, in distributed systems, things can go wrong. And it's not about why things went wrong is one part. When did things start going wrong is another part. And being able to actually arrive and fix things in, as they call it, as a mean time to detect and a mean time to recover, right? The MTTD and MTTR. Being able to build and reduce some of these things, that defines largely the success of any business. I mean, it's quite easy. Just as we are one of the very many financial ecosystem providers, there are tons of providers in the world. So the customer has tons of options to switch over from one place to the other place, right? for any business to be, in its true sense, reaction to some of these things, I think is more important. And tools like Hypertrace or any observability tools, they sort of help actually bring down, put things in control rather than just leaving it to hypothesis.
Jayesh, please explain to us how Hypertrace specifically gets you to that reduced mean time to detection and remediation. What is it about it in the way it's being used that cuts that all-important time down so that user experience is better?
So as Venkat was talking, in the modern systems, there are too many unknown. So finding like what caused any problem at any particular point in time is hard. And how Hypertrace is trying to help in this is we have entity-focused, API-first views. So Hypertrace provides you very detailed service dashboards, even a overview, like out of the box, the service overview, API overview, and backend overviews, which will help you find like what different services are talking to each other, how they are talking to each other, the interaction between different services, then what different APIs your service is talking to, list of those APIs, latency, call wait, error rate metrics out of the box in those lists. And it provides you a first pane into the whole, your service and API trace data. Like whatever insights we got out of that trace data is what makes it easier to find which API or which service has some issue. And that's where this entity first view and that's where this API first view makes more sense. And as I said, those service dashboard, API dashboard are what help people to get into finding an issue very easily. And that's where the mean time to detect an issue and mean time to resolve after that is what we are solving, sort of.
Just to add to what Jayesh mentioned, right? Very specifically in our world, in Razorpay's world, also our ecosystem is internally a Kubernetes first ecosystem. So on what that means is Kubernetes inherently is extremely dynamic in nature. You're not anymore dealing with single private IPs or public IPs or any of those things. Services can come up, pods can come up, deployments can come up, go down. Service discoverability becomes a problem. So which basically means that tying back a particular behavior of all the way from tying back a behavior of a particular pod to tying back the behavior to the service itself, to the collection of services itself, to the underlying infrastructure aspects, whether we are talking about queues, whether we are talking about Kafka, whether you're talking about any number of these interconnected infrastructural components as well, that becomes extremely challenging. The second aspect to that is also implicitly most of our ecosystem sort of runs on preemptive workloads or spot workloads, right? So nodes can come up, nodes can go down, right? Overall, this also means that how do you sort of put these things together? While we identify that, this particular service is problematic, I might probably want to find out, is it just the service that is problematic, or is it the underlying hardware that is problematic? Is it within the underlying hardware? Is it just a particular pod that is problematic, or the entire node that is problematic? While that's one view, the other view is overall cardinality, for example, becomes an extremely important issue. Metrics cannot solve that problem. Logs cannot solve that problem. A very simple request, for example, like a payment create request in our world, carries at least about 30 to 35 different cardinality dimensions. The merchant ID, it's the gateway, it's a terminal, it's a network, it's a bank, whether the payment is from an international merchant or not, the type of the payment, variety of other parameters sort of comes into place, right? So, which also means that we just simply cannot say that, hey, the call ratio for the payment create request has actually gone down. We also need to know, is it overall? Is it at a particular merchant level? What particular dimension? So the entire drill down, funneling, and being able to sort of really narrow down the problem in a tight production scenario. I think those aspects, tools like Hypertrace or any observability tool for that matter, tracing in general, sort of makes it extremely easier to sort of arrive at these conclusions.
You mentioned that there are other options for tracing. I wonder how you came to use Hypertrace. What's the story behind your adoption of Hypertrace, and what did you look at otherwise?
So we started our distributed tracing journey. So we were largely on an APM, PaaS APM tool, till sometime early last year. We sort of realized that we had to go into distributed tracing primarily because the APM was not solving a lot of questions that we were sort of asking the APM tool. So when we started foraying into distributed tracing, like everybody starts, we started with Jaeger implementation. Jaeger seems to be like the de facto simplest way in which you can get things up. Alongside that, we went ahead to evaluate a whole lot of PaaS vendors. I don't want to take the names. We went ahead to sort of work and evaluate whole lot of PaaS vendors. So there were a couple of challenges in some of the past vendors. So either the issue was with respect to some of the storage in terms of the traces and being able to sort of drill down some of those things. Some of them had imposed certain infrastructural requirements on our side, with respect to the number of containers that can run on a node, etc., etc. The third was the way they were charging in terms of whether it is to do with number of users or number of services. Most of these things became extremely prohibitive for us in one way or the other, which means also many of the providers, for example, were just giving us like an Agar++. While Agar is open source, they were just giving us an Agar++. So the overall cost benefit ratio in terms of, so we are also growing with the number of services and users, right? So any kind of a model that sort of charges us on a user level or a data storage level or a service level, these become prohibitive over a period of time. And we have learned this in other places as well. So what we were sort of, in all honesty, we didn't want to build an observability tool because building an observability tool and maintaining it in-house is probably not the most natural, business order for us, right? But when we started evaluating and going through this wild goose chase, we sort of realized that it's best for us to sort of do this in-house. And then we were sort of doing some random Google search, and then I just hit upon, me and one of my colleagues, we just hit upon this thing called Hypertrace, and we said, oh, okay, the name sounds interesting. Let's go ahead. And then we found this, we said there was a nice search bar which said put in your email address and jump into our Slack call, Slack channel, and that's all I did. I just signed up. In fact, I did not even sign up with my company email address. I signed up with my personal email address. I just logged onto jumped onto their Slack call, and I think the first question that I asked them was, "Hey, you have this whole HC collector. We are using an OpenTelemetry collector. Tell me how is it going to interpret?" And I think Lakshman, Jayesh, and a whole lot of other folks came in. Then it was just a whole Docker Compose experiment from the GitHub. The integration was quite straightforward. We just did a whole set of POCs and all that. And then we said, okay, this sort of makes sense. I think the first UI that we saw was almost on par with any commercial SaaS providers user interface, right? So that sort of blew my mind. Just how can an open source product actually build such a fantastic UI? I think that was the first thing that sort of hit most of our heads. And I think that was the biggest role sell for us. And we said, let's just jump in and see how it evaluates. And yeah, that's the story.
And what sort of paybacks, what sort of metrics of success have you enjoyed since adopting Hypertrace? And why, as an open source project, are you able to inject your own requirements or desired functions and features into it?
So, like I said, right, so we started this journey we were sort of a little late to the party in terms of the whole distributed tracing business. So what we had done over a period of time was first and foremost understand the beast that we were sort of dealing with, right? Which also means that we had to internally build a whole lot of instrumentation and SDKs, whether it is building the whole OpenTelemetry or open tracing agents. In certain cases, we had to build certain folks on some of the open source projects like OpenCensus, integrating some of those things, being able to standardize. So there's also challenges in terms of standardizing, being able to internally standardize all of our instrumentation, being able to put out the best practices, ensuring that a lot of applications can sort of adopt. Because adoption, while it seems simpler, adoption still works. We have to reduce internal developer adoption by building the right toolkits, by building the right frameworks, by building the right SDKs. Because applications have their own business lifeline, and we shouldn't be adding to that existing lifeline by throwing in one more process, right? So we formulated a virtual team internally within Razorpay, which has now become like a full-fledged team in terms of building this whole observability stack. And then we started building all of these SDKs and all of this tooling, went ahead to instrument a bunch of apps ourselves, went ahead to do a lot of adoption exercises within the organization. And now we have a handful of critical services. And when I say handful, it's at least tens of critical services that are at least, which are in the critical flow, are already there on Hypertrace. One of the biggest benefits that you're sort of seeing is while production monitoring is one side of the story, there's a whole lot of use cases that our internal engineering teams actually figured out with respect to pre-production, which is largely in terms of running chaos tests, which is largely running in terms of performance tests. Now, some of these things wouldn't have been possible before, being able to sort of pin down the right problem areas. I mean, I wouldn't say it's not been possible. It wouldn't have been easier before, right? So now, during the performance testing or doing some of these chaos testing, engineers are able to, really pinpoint the root cause of the problem, and they've gone back to fix their code before even the code goes into production. And we believe that that's actually a lot more valuable for us than the code going to production and then surfacing these problems out. So we're able to catch a lot of these things right within our pre-production environment itself, while production monitoring is secondary. The problem or the misfortune about all monitoring tools is that the typical product metrics in terms of monthly active users and daily active users might not probably be applicable for a monitoring tool. Why? Because when things go right, nobody wants to look at monitoring. It's only when things go south that people actually log on to a monitoring tool. So a hard number in terms of how many users are using this might not be a good number. It's in terms of how many issues we're able to sort of detect from the tool and being able to sort of in much earlier stages of development. And that's probably the biggest benefit that we have been able to largely draw.
Jayesh, it sounds like what Razorpay enjoys is the ability to have a role in how Hypertrace evolves and being able to be guided, in a sense, to their needs and wants. Tell us a little bit more about what makes Hypertrace unique. What are the advanced features that some of your other users have been able to bring to the table stand out? What is it that you can do with Hypertrace in the market that is unique?
There are two ways to analyze this data, visualize this data, maybe use this data to understand the systems. First important thing here is how we do data collection. So Hypertrace provides you a data collection from any sort of standard instrumentation. So even if your application is instrumented with Jaeger or Zipkin or OpenTelemetry, and you start sending that instrumentation data to Hypertrace, we will be able to analyze, we will be able to show you those scattered dashboards, show you those, you will be able to slice and dice on the data through our Explorer, and you can do a lot of different things. So this democratization of data collection aspect is what is one important thing Hypertrace provides. So there's no vendor lock-in. Tomorrow, if you want to move to any other service, if you want to use any other tracing platform, you can do that with Hypertrace because we support all the standard instrumentations. Next thing is how we utilize that data. So most of the tracing platforms, if you go out there, provide you a way to slice and dice on that data. So there's just one Explorer view where there's all the data from the instrumentation available, and you go ahead and slice and dice, find the information you want. Ask the question and then you will get the information. That's the one way to look at it. What Hypertrace provides in addition to that Explorer view, we have an Explorer, we provide slice and dice. What we provide in addition to that is a detailed service graph. So where you go to application flow, you see the service interaction, you see the latency-wise marking, you see what services are being aired out right now. Detailed service dashboard, which is derived from trace data, obviously, which is derived from your instrumentation data. But it provides you necessary metrics out of the box, which are latency, error rate, call rate. So those numerical metrics as well as visualizations are available there out of the box. You see what are your top endpoints, what are your API interactions. You also see the health radar, which provides you the comparison from last hour's data to current data. Whatever your latency was in last one day to last particular hour, it provides you comparison for that. And it's pretty helpful in a lot of ways. So right now, I know one of the use case Razorpay has for that is they use this to compare in between deployments, I guess. So in between deployments, if the performance is affected or latency or call rate is changed, latency or error rate is affected in a way. And there are a lot of use cases you can solve with Hypertrace. So in general, whenever we talk about observability, right? So there's as we discussed in brief that there's one particular thing, that early problem detection, how you can reduce MTTD, how you can reduce MTTR. And this dashboard, this service view, this application flow, all these things help you to solve these problems easily, achieve this early problem detection easily. Then there's availability. So whatever we are doing right now is to make our applications available. The expectation is 100%, but maybe 99.99% type. And in case of Razorpay, I guess it's very critical, right? So the downtime actually has a business impact. And in most of the businesses, that is the case. So availability is a critical issue, and we provide. And as I said, the dashboards help you to do that as well. Then currently we are working on alerting as a feature, which will alert you on deviations. And these deviations are calculated automatically. So we calculate baselines on from the previous data, and whenever the deviation happens, we'll give you an alert, and that will obviously help in reducing mean time to detect the problem as well as increasing availability in general. So yes, this kind of features what Hypertrace provides makes the user experience more seamless. And as Venkat mentioned, we have a very beautiful UI, and that kind of attracts people as well. So that's one of our power at the moment. And why it looks so professional, why is it very attractive in the first place, that also has a story, right? So whatever we are building right now is in a SaaS perspective, is for our application security platform, which our customers are using. But this functionality also goes in the Hypertrace. And it helps community, it helps people like Razorpay, like Venkat, to solve the problems in their environments. And that's pretty good.
Venkat, for other organizations that are facing a similar complexity and need for speed to remediation like yours, that are very concerned about making sure their user experience is top notch, what recommendations do you have? What should other companies be thinking about as they evaluate observability and tracing? What do you recommend they do as they get more involved with API resiliency?
So one fundamental problem that sort of exists today in the open source world, largely with respect to tracing, is the evolving standards. We have open sensors on one side, Zipkin open sensors on one side, to open sensors going to open telemetry, and open telemetry actually going to, open tracing, and open tracing actually going to open telemetry. While open telemetry is largely nascent and it's sort of forward looking, open tracing is sort of trying to keep it compatible with open telemetry. And open sensors is sort of not, except for specific places, it's not largely relevant, right? So, which also means that a lot of today, there is not a lot of automated way. In certain places, there are automated ways, but in specific language frameworks, there are not automated ways to do, automated instrumentation, like what agent, like APM agent sort of solves, which means that there is a certain amount of work that the internal engineering community of a particular organization needs to do when they're picking the right standard and picking the right tool. While, like I said, while it might sound like poetry in terms of our integration with Hypertrace, it's not an easy job in its sense. So my only recommendation would be that today, a good example is that one good thing that works for us is that we have an extremely mature DevOps organization. We have extremely mature DevOps tooling and infrastructure tooling, right? So we were slightly overwhelmed, but we are not sort of afraid of the stack that Hypertrace actually comes up with. But for a small startup, which is sort of just building up things, it might look quite daunting to actually go ahead and build their own observability stack, so to speak, right? Which means that either to begin with, my only recommendation would be to start with an existing PaaS provider. As you sort of build the right experience, as you sort of build the right tooling internally, right? As you sort of vetted some of these things internally, then go ahead to evaluate whether it's the time for you. And that solution, the moment you go into a PaaS solution, while it might work in the initial days, over a period of time, it becomes, like I mentioned, cost prohibitive, right? At some particular point of time, we have to start looking inwards. At that particular point of time is when systems like Hypertrace sort of become quite useful for an organization. In the early stages, sorry, Jayesh, I might not sound perhaps marketing around Hypertrace, but the real truth is it's not easy to build your own observability stack. So I would first recommend any organization to experiment with a SaaS provider of lower scale. Once they get the right practice, then go ahead to invest in the right tooling that is probably necessary, because that sort of gives you also the liberty to not maintain the stack and also maintain the tooling. You can keep the internal tooling separate, experiment, and then come back. That's probably what I would recommend. Again, a different organization at a different scale altogether where cost becomes an issue, there you just need to look at features. You just need to look at a bunch of other things in terms of cost. Again, cost is not just the physical infrastructure cost or the licensing cost. Cost is also engineering cost. If the stack goes down, who monitors the monitor is a bigger question, right? We have observability, or Hypertrace, but who monitors Hypertrace, right? That becomes the next question. That's an operating cost that the engineers in the organization need to undertake. So these are some of the trade-offs that we have sort of seen in the past, right? And there is no right answer, but I think it's a journey, and anyone will sort of find the right path as they navigate through the journey. And as we speak, in fact, after our experience with Hypertrace, I have actually connected with a couple of my friends in different organizations, and I've actually told them some of the benefits. I do not know if they've reached out, but I've actually told them some of the benefits that we have sort of leveraged using Hypertrace. So that's what I've been able to do, at least from my side.
Just to follow up on your advice for others, Venkat, what advice do you have in specific terms around an open source project? Those trade-offs you mentioned must come into play. What is it about open source that helps with those trade-offs?
One particular advantage that we sort of have with open source is that there is no vendor lock-in, right? I mean, you're not growing and paying or building with the cost of the vendor, or you're not really at threat in terms of, what are the things that the vendor could sort of change? What are the licensing policies or the costing policies or the relationship policies that the vendor could change? That's one major advantage. More specifically in our world, we have a requirement for us to have actually gone ahead with one specific class of application. We had to use OpenCensus implementation. As we started navigating through OpenCensus implementation, we sort of realized that specifically OpenCensus for PHP, we started realizing that there were quite a few issues in the SDK itself. So we literally went ahead. There were memory issues. There were a whole lot of other issues. So we had literally gone ahead. And this was a complicated code. It was a combination of a lot of C code along with a whole lot of application code. So we had actually gone ahead to, fork the code, make a lot of changes. Today, we can proudly claim that PHP OpenCensus repo actually points to our fork as the best industry fork in the community. And we are working with the community, with Hypertrace community in terms of actually being able to build some of these features, whether it is through design, whether it's through code, whether it's through knowledge sharing, bug fixing. And I think for us, at least, I think I'll let Jayesh say whether I'm right or wrong, but at least for us, it's been an interesting and exciting journey. And I think, that's the word that I would sort of use.
It has been the mutual experience from our end as well, because we learned a lot of things. So we made some assumptions in the beginning that this is what user might expect, or this is what, and we all do that. Like while building a product, we all do that, okay, like this is what I think user might expect out of this. And this is I think is a user workflow at this point. But Razorpay was very working with us on finding out these problems that, okay, dude, this is not going to work. You have to change this part, or maybe like this consideration might not be right at this point. And we worked backward. We changed some things. We modified some things. We added few features. We removed few things. And that's how it came to a point where it is today. And even like maybe Venkat will agree on that part, that when they started, at that point, it was completely different thing. And right now it has evolved in a very good way with the whole collaboration aspect, I guess.
Yeah, just to add to the scale, despite the fact that we have a handful of critical services today that are sort of instrumented, just to give, what you're sort of dealing with, right? So for a fraction of critical services that is instrumented, today our trace volume is almost close to about 2 terabytes a day. And while that is a good problem to have, we have other interesting scaling challenges that we sort of need to deal with. And how do you optimize some of these things at scale, right? That journey and that feedback and that working together model is probably what, at least we cherish largely, right? Had it been a traditional SaaS provider, we could have just gone ahead and said, hey, this sort of doesn't work. We stick to them for a few months. Then we go ahead to another SaaS provider and say, are you going to solve this problem or not? While the flexibility that we get in open source is that, okay, here's a problem. How do we fix it? And because the code is under our control, right? I think that's super powerful when you sort of look at it in the overall scheme of things.
We all learn together.
Yes, it sounds like a partnership type of relationship. Jayesh, before we sign off, and we're almost out of time, tell us a little bit about the roadmap for Hypertrace, and particularly for the smaller organizations who might prefer a SaaS model. What do you have in store for them?
Yes, so the roadmap is pretty interesting for upcoming quarters. As I said earlier, that we are currently working on alerting, which will be there in a week or so, like this month's release. So the anomaly detection-based alerting will be there. Then even you can set your baselines, and though that part of alerting will be there in the second phase as well. Then we are working on metric ingestion and then integrations throughout the Hypertrace platform. So as we were discussing during the course of the whole podcast, that one important aspect of tracing or in general observability is correlation. Being able to correlate the data, being able to propagate that context throughout the system is very important, and that's what we will be doing with our metric integration. So you will be able to send application metric, you will be able to send infrastructure metric to platform, and you will be able, we will be correlating that to trace data, log data, and those user workflows will be very well defined at that stage. So that is thing I'm pretty much excited for. And apart from that, several optimizations throughout the platform will be there as well. And talking in a SaaS perspective, like we had a few conversations earlier where smaller company, as Venkat also mentioned, that it works very well for an organization which has very mature DevOps structure, which is very mature DevOps organization, and they can deploy it, they can manage it well. But when it comes to smaller organizations which have maybe 10, 20, 30 developers working and not a very well-defined DevOps team, it gets very hard to deploy this kind of platform and trying to manage. For those users, we are working towards a SaaS model, which will be there will be a free tier for which will satisfy, I guess, most of the smaller needs for most of the smaller companies. And we will be launching that part soon as well. So once we have the SaaS part, I guess whatever the issue Venkat mentioned with the smaller companies, they will be able to address that.
Wonderful. Now, where can organizations go to learn more about Hypertrace and perhaps get in line to start using some of these features and functions and maybe even become a partner at the same level as a company like Razorpay?
So you can head on to hypertrace.org. That is our website. And you will find most of the details around use cases we are solving, our Slack channel link, GitHub link, everything available there. Apart from that, if you want to check out GitHub, it's github.com/hypertrace. And again, you will find the Slack channel link, so Slack workspace link, as well as if you have any issue, feel free to drop in the GitHub discussions and we will be able to address that as well. So if you want to learn more, hypertrace.org and docs.hypertrace.org will be places to start with.
As a first-time consumer, in fact, again, I would exactly agree with Jayesh, which is the website, the documentation, Slack, GitHub. I think that's the order, and that's quite easy. Actually, if you want to just try it firsthand, just go to github.com/Razorpay/Hypertrace, clone the code, do a Docker Compose up, and within a few minutes, you should actually have the entire stack up and running. That's as simple as simplicity can get. And for further details, I think the best way that at least we have tried to figure out is just go to the Slack channel and start communicating. And I think that, like I said, I mentioned this earlier, and at the cost of mentioning it again, this team is super duper helpful. I think they are super duper responsive, super duper helpful. We don't have, in fact, we have never had to talk to them saying that, hey, what's the SLA? Because we sort of realized that they have actually come back with a patch much faster than we can actually imagine. So yeah, that's pretty much what I would like to say.
Well, very good. I'm afraid we'll have to leave it there. You've been listening to a sponsored BriefingsDirect discussion on how the speed and complexity of microservices-laden applications can often leave developers in the dark as to what's going on with their underlying dynamic service architectures. And we've learned how a sophisticated distributed tracing and observability platform called Hypertrace discovers, monitors, visualizes, and optimizes services for an innovative online payments business, Razorpay. So a big thank you to our guests. We've been joined by Venkat. He's an architect at Razorpay in Bangalore, India. Thank you so much, Venkat.
Thank you so much, Dane, for the opportunity, and thank you, Jayesh, and the entire Hypertrace team for helping us build and secure and make our systems far more robust. Thank you so much for the time. Wonderful.
We've also been here with Jayesh Shahar. He's the founding engineer at Traceable AI and a product manager at Hypertrace. Thank you so much, Jayesh.
Thanks, Dana. It was great talking to you, and thanks, Venkat, for your time and being here with us, telling your story, which will help a lot of people to get to know about Hypertrace, get to know about how others are using it, and probably will help us in more adoption.
And a big thank you as well to our audience for joining this BriefingsDirect API resiliency discussion. I'm Dana Gardner, Principal Analyst at Interarbor Solutions, your host throughout this series of Traceable AI-sponsored BriefingsDirect discussions. Stay tuned for more podcasts in our series of deep dive discussions on the burgeoning API economy and for new tools that are arriving to gain better insights and resiliency into API use and security. Thanks again for listening. Please pass this along to your business community and do come back next time.